do the Chapter 13 review this morning. It doesn't feel like it's a terribly long review, and as always, it probably would be better if you had the review done before you watch the video. Kind of treat the review more like it's a test than not. That would be the best thing to do. But I started problem 1 already just to speed up the process. So I'm asked to make a frequency distribution, and the frequency distributions in this chapter, we made 2 columns. The second column is going to be the how many. We could call it the quantity column. And then the first column needs to be what I'm counting, the name of what I'm counting. And in this problem, the data pieces up here, the things that I'm actually counting, are students' test scores, because this shows the score of 20 students on the Chapter 12 test. And so the name of what I'm counting is I'm counting test scores, and the quantity, it's the number of students that had that range of test scores. And it tells me to make the beginning class 50 to 59. As I look at this, I don't see a test score over 100. So when I go to make this up, I'm going to go 50 to 59, which are kind of, I guess, the F's. And then it just seems natural to make it 60 to 69, 70 to 79, 80 to 89. And here's where I'll have a little bit of flexibility. Our author would insist on a category, the next category being 90 to 99, and then 100 to 109, because our author wants all the widths here to be the same. I would be okay if you put 90 to 100 for this last category and didn't separate the hundreds from the 100 from the 90. But because the highest score was 100, somewhere in these columns in my bottom category, I needed to be able to catch 100, and our author wouldn't be happy with writing 90 to 100 for the last category. But in reality, this is kind of F, D, C, B, and A, and if you did 90 to 100, I'd be content with this. Before I fill up the right-hand column, I need to search the data. The first number I'm going to put next to 50 to 59 are all the 50s. So I'm going to go through the list and find out how many 50s there are. There's a 55 I see. There's a 58 I see. I only see 2 50s, so next to the 50 to 59, I'm going to write a 2. Now I'm going to search for my 60s. I see a 61, a 61, a 68, so I see 3 60s, so next to the 60 to 69, I'm going to put a 3. Now for my 70s, I see a 77, a 75, a 73, and a 73, so I'm going to put a 4 next to the 70 to 79 because there's 4 of those. And then for the 80s, I see 85, 85, I see 2 80s, and now what you might write is different than mine. I see 4 90s and 4 100s. If you put an 8 next to the category of 90 to 100, I would live with that, as well as if you put a 4 next to the 90 to 99 category and a 4 from the 100 to 109 category. So if you use this category and picked an 8, I'd live with that just completely fine. So that's a reasonable answer. One easy way to check it that I haven't missed anything, I was told there were 20 students that were surveyed. I should be able to add the numbers up in this right-hand column. They should add up to 20. If they don't add up to 20, or I missed a number, or I've double counted something. So let me just go 2 plus 3 plus 4 plus 2 plus 4 plus 4, and I get 19. I'll be darned. That sucks. 5, 9, 11. Only get, and it looks like I missed a 90 here. it looks like there are 1, 2, 3, 4, 5 90s. I think I did this when I shot the video for this section. So that number should have been a 5 and not a 4. So it was a really good idea that I took the time to add the numbers in the right-hand column, made sure they added up to the number of data points, because it's really easy when you're going through and making this right-hand column to miss something. So let me fix that. And that being the case, if you did the 90 to 100 for the last grouping, should make it a 9. So both of these answers are equivalently correct for my purposes. Our author would not like this 90 to 100 for the bottom category, but I definitely don't have any issues with it. Okay, so problem 2 wants me to make a circle graph. And for a circle graph, I'm going to put percents in my circle graph. And in order to find percents, I'm going to divide the quantity in each of the right-hand columns by the number of the total that the circle represents. So as I read through this, I might have to update this pretty soon here if we get a new president. It says a sample of 200 people were asked what their favorite president was living. And those are all still living. So I'm going to make a circle graph, which I'm just going to draw a circle. And inside the circle, I'm going to cut it up into regions. And for my purposes, I'm going to put percents in the regions. And to figure out the percent, I'm going to divide each of the numbers by 200. It's actually going to give me a decimal, then I'm going to move the decimal over twice to make it into a percent. So if I do 50 divided by 200, I get 0.25. And I'm going to write that as 25%. And if I do 60 divided by 200, I get 0.3. I'm going to write that as 30%. And then 80 divided by 200, I get 0.4, which I'm going to write as 40%. And 10 divided by 200, I get 0.05, which I'm going to write 5%. You could change these to degrees by multiplying by 360, the decimal. I think percents are just as easy for me to work as degrees. So I'm not going to be really nitpicky about how perfect your pie chart is. It should be the case that the Bill Clinton sector is the biggest because he has the highest percentage, and that the Barack Obama should be the smallest. And other than that, I'm not going to be too picky. Certainly not a Republican, although I made the Republican numbers bigger. I think that was just trying to be somewhat politically correct so that I didn't appear to be favoring the Democrats for what it's worth, but hardly matters. So when I do this, 25% is easy for me to get because that's a full quarter of the circle. Make a dot in the center of my circle, and then somewhere I need to make a quarter of the circle. And in that, I'm going to put I don't know that he's really a junior, but I'm going to call it junior, and I'm going to write a percent next to it. So that would be a reasonable representation of a sector that represents George Bush Jr. And then the father's, because he has a higher likability, I'm going to make his region a little bit bigger. And it's bigger than a quarter of a circle. It doesn't matter where I have it, but just so it's slightly bigger than a quarter of the circle. And then our author, when he did the pie charts, puts names and percents in the circle. So I just did that to be consistent. Bill Clinton needs to have the biggest section. So because it's 40%, it needs to be bigger than any of the other two circles. And Barack Obama needs to have the smallest. If I just make a slice here, as long as this is the biggest, if this is bigger than the George Bush Sr., maybe it's not. Maybe we make it a little bit bigger this way. So I'll call this whole region here Bill Clinton. And make it 40%. in this little region here, I'll call it Barack Obama. We'll make it 5%. So anyways, that would be a reasonable pie chart for this situation here. And as long as the pieces that you make are relatively close, I'm not going to take a protractor and measure. So the 40% should really be the biggest region. 25% should be that should be easy. That's just a quarter of the circle. And you don't have to have yours in the same position. If you had Bill Clinton over here and George Bush Jr. over here and Barack Obama up there, there isn't anything right nor wrong about where your sector lies. So something like this, and I'm not going to be that picky when I grade on the pie chart, because really, if I was going to do a pie chart, I would just have Excel do it, and it would make it perfect for me. Three gives me a frequency distribution. It wants me to make a frequency histogram. And when I make a frequency histogram, which is a bar chart, along the bottom axis, I write the entire class. Our author writes the midpoint of the class. And then on the vertical axis, I write the quantities. And I'm certainly not going to increment by ones to get the y-axis, because the numbers are just too big. It looks to me like if I increment it by 50s or 100s, I'd get a reasonable graph. I'm going to try to increment by 50s. If you increment it by 100s, that might be better. I'm afraid I'm not going to have room if I go by 50s. Should be the case that every little tick mark I make on this vertical axis are equally spaced. So in a frequency histogram, which is a bar chart, the vertical axis is going to accommodate the numbers in the right-hand column. The horizontal axis is going to accommodate the categories. And I took the name of the categories and the name of the right-hand column and just kind of wrote them next to each column. And I would have written grade under here, but I didn't feel like I had room. And now there isn't anything right or wrong about writing the 90 to 99 category first or last, but I'm just going to write the categories in the way they're written. So I'm going to write 90 to 99, 80 to 89, make little tick marks for where the center of those are, 70 to 79. And our author would write, like, instead of 90 to 99, he would write 94.5, which is the number halfway between 90 and 99. He'd write 84.5, which is the number halfway between 80 and 89. To me, that just seems odd to do, but if you did that, that's what our author would do. If you wrote the columns backwards, if you wrote 50 to 59 first, 60 to 69, 70 to 79, 80 to 89, 90 to 99, that's somehow what I would intuitively do, but it's okay. I just took the order that they're written in. Now above each of the little tick marks, I'm going to make a dot for the height. So above 90 to 99, my height needs to be 100. Above 80 to 89, my height needs to be 300. Above 70 to 79, my height needs to be 200. Above 60 to 69, my height needs to be 150. And above 50 to 59, my height would be 50. If I was asked, and if I was doing part 2, the frequency polygon, I would connect each of these dots with line segments. Because I'm asked to do a histogram, I'm going to make rectangles to carry these, or to make my picture finished. So when I go to do part B of this question that asks me to take the same data and make a frequency polygon, the beginning of what I'm going to do is going to be identical. A frequency polygon is similar to a frequency histogram in that it shows the same information, But instead of making rectangles to carry the figures, I make line segments. So I'm kind of simultaneously sneaking in both parts A and B. This should probably be lower. So part A gave me this grade data and asked me to make a histogram. Part B gave me the same grade data, asked me to make a frequency polygon. My graphs at the very beginning stages could be identical. I couldn't tell the difference between the top one that's going to be a histogram and the bottom one that's going to be a polygon. A frequency histogram, I put the categories along the x-axis, the quantities along the y-axis. I mark a height, and then I connect the heights with rectangles. Our author makes the rectangles connect so that their edges connect. They really don't have to, but I find that they do. So to make a frequency histogram, which is a bar chart, I'm just going to connect all my points or make a rectangle with a little dot in the center of the rectangle. If I'm making a frequency polygon, I'm going to take each of the dots and connect them with lines. So this top graph I would call a frequency histogram. Call it a bar chart in reality. And the bottom graph we call a frequency polygon. I might call that just a line graph. Both of these I'm being slightly inconsistent with what our author does. Our author on the x-axis would never show the whole category, but I like that better. Our author for this 90 to 99 would write 94.5, for instead of 80 to 89 would write 84.5 and so forth. So our author wouldn't write the whole range down. And our author software for the frequency polygon would have the graph extended to the x-axis. So I extended it in blue. I don't really think that's proper, but our author software does that, and if you do that to be like our author, that's okay. So both of these are fine. If you did the homework in the text and you notice that the author, instead of showing a separate graph for a frequency polygon and a frequency histogram, if you showed the polygon and the histogram on the same graph, that would be fine. So if this was a test question and I asked you to do both, if your graph to part A showed both the histogram and the polygon simultaneously on it, I would call that perfect. So this is both a frequency histogram / polygon. It's a double graph that shows both parts simultaneously. I would probably do that, and since our author did that as he was making the keys in the back of the book. On a test question, if I asked you to make both a histogram and a polygon for the same set of data, I'm completely content with you just making the histogram and putting the lines over it. But you can do two separate graphs as well. You don't need to shade in your bars, but if you really felt the urge to shade these in a little bit, you can darken them in as much as you like, but you don't have to. Okay, I'll leave that graph. Part B gives me a histogram, asks me to answer some questions with regards to the histogram. You notice I made this histogram using Excel, and it was hard for me to get the bars connected, so my bars aren't connected on my histogram, which there isn't anything wrong with that. If I was going to ask and answer questions with regards to the histogram, it wouldn't hurt to make a frequency distribution, so I clued myself into that I'm going to do that. So what this graph shows, it shows scores on IQ tests, so scores can be between 80 and 99, 100 and 119 and so forth. So the people that took this IQ test had IQs that were broken up into one of a few categories. I don't know that this is absolutely necessary to make the frequency distribution, but I'll do it anyways. Now for each category, there were 2 students that had IQs between 90 and 99. There were 16 students that had IQs between 100 and 119. There were 4 students that had IQs between 120 and 139. There weren't any students that had IQs between 140 and 159. And there were 2 students that had IQs between 160 and 179. If I add these numbers up, I get 24. So 24 students were tested. All right. Now that I have that frequency distribution, it makes it easier for me to answer the question, how many students had IQs of at least 100? That's all of these students right here. Anybody that fits into one of those categories has an IQ of 100, at least 100 up to 169. If I add those up, I get 22. How many scores does a histogram represent? I've already answered that question by summing up my right-hand column. There's 24. And how many students had IQs less than 100? That's just these 2 in the that had IQs in the category between 80 and 99. So although it wasn't necessary to make a frequency distribution to answer the questions, having the frequency distribution handy made it easier for me to answer the questions rather than having to look at the histogram. So if there's a test question that asks questions about the data in the histogram, a nice thing to do would be just to make a frequency distribution, then use it to answer the questions. Problem 5 wants me to do a mean, median, mode, and mid-range. Mean is just adding up and dividing by the number of data. So the mean, I'm going to add up all the data pieces. 2 plus 2 plus 2 plus 3 plus 4 plus, I wish I didn't put so many, 6 plus 7 plus 8 plus 8 plus 9 plus 10 plus 11 plus 15. And I have to divide by the number of items. There's 1, 2, 3, 4, 5, 6, 7, 10, 13. Looks like there's 13 different items there. So I'm going to add them up, all the data pieces, 2 plus 2 plus 2 plus 3 plus 4 plus 6 plus 7 plus 8 plus 8 plus 9 plus 10 plus 11 plus 15. I get 87. Now I'll take 87 divided by 13. And it doesn't tell me where to round. I think we've been rounding to 2 decimal places, so I'm going to write 6.69 for the mean. I'm going to double check myself because there's a reasonable chance I could have messed up. So I think 6.69 is the perfect answer for the mean. The mode is the data piece that occurs the most, and in this case, the 2 occurs the most. It occurs 3 times, nothing else occurs 3 times. And had another number like 8 had it occurred 3 times, I'd probably write 2 comma 8 and said it was bimodal, having 2 modes. I think I might live with going up to 3 modes. Once we'd have more than, if we had more than 3 modes, I just say there's no mode. I skipped the median because it's the most tedious one. To do the median, you have to have the numbers listed from largest to smallest, or smallest to largest. And then you start crossing out the first and the last, second and second from the last, third and third from the last. You do this until you're down to 1 number. If you get down to 1 number, that number is the median. Or if you get down to 2 numbers, if you get down to 2 numbers, you have to add those numbers and divide by 2 to get the median. So as I'm ticking in here, it's beautiful that it ends up with 1 number. So the median's going to be 7. Let me do the mid-range, and then I'll sneak another median on this sheet just so you can see another kind of median. So this is the nicest kind of median where I listed the numbers in order and I started crossing out from the edges and I was left with 1 number, but it could be the case that you're left with 2 numbers, and I'll do a quickie of that. The mid-range, to find it, you add the low number, which is 2, plus the high number, which is 15, and divide by 2. This I can do without a calculator. This is 17 over 2, which is 8.5. So I'd say the mid-range of this data set is 8.5. So that's completely answering all the questions that were asked for number 5. This isn't a review question, but this is something that could wind its way up on the test. If I gave you this data and said find the median, first of all, the data is not written in ascending order or descending order, and to find the median, you have to have the data listed from small to high or high to small. So I listed it from small to high. And now I'll mark out the first and the last, the second and the second from the last. If I marked out the next two, I wouldn't have anything left to say this is the median. When you mark out and you're left with 2 items, you find the median by adding those 2 and dividing by 2. So for this data set, the median would be 5 plus 6 over 2, which is 11 over 2. I think that's 5.5. So that could make its way into the test, although the problem on the review that had me compute a median, I didn't have to do any fancy work. It might be the case on the test that you might have to do that little extra work. The last 2 problems want me to find, oops, I'm sorry. Problem 6 wants me to do a test score thing, and talks about Jess, and it says that you need to average 70 on 8 exams to pass the course, and it gave me Jess's grades on 7 tests, and I want to know what she needs on her last test. And to do that, to figure out a grade that's needed, you find the points needed for the grade, and you subtract the points that you currently have. It says to pass the course, you need to get an average of 70 on 8 tests. If I multiply those 2 numbers, an average of 70 on 8 tests, 70 times 8 is 560. So for this particular class, you would need 560 points to pass the course. And if I add up just the scores, which were 90 plus 70 plus 88 plus 71 plus 42 plus 98 plus 77, I get 536 that she already has. So if I take the difference between the points that were needed and the points that she has, that's what she's going to need to get. So she needs 24 points for a B. Part B says you need an average of 80 to get a B. How many points would she need on her 8th test to get a B? And I'll do the same thing. I'm going to do points needed minus points have. She still only has 536 points. She needs to average 80 on the 8 tests that she's going to wind up getting graded on. 80 times 8 is 640. So you need 640 points for a B. If I take the 640, that's the total points needed for a B, less the points that she already has, I get a, this last one should be 24 points for a C. This should say 104 points for a B, which means if the test is only worth 100 points, that you'd need some extra credit or somebody to curve your grade to get that next higher grade. Last question wants, there's 2 of these. This question wants me to find the range and the standard deviation. The range is just the high minus the low, and that's easy to do. For problem 7, I give you the data, it's in ascending order, but it doesn't need to be in ascending order. The range of any data set is just the high minus the low, so the range of this is going to be 7. And for the standard deviation, we could do it by hand, but you don't have to. I'll do it by hand quickly, but if you know how to do it on your calculator, that's fine. To do the standard deviation by hand, I need to find the mean. I add up all 6 data pieces, which is 4 plus 7 plus 6 plus 5 plus 9 plus 11. I get 42. Divide by 6, I get 7. And then I'm going to make up a column. I'm going to write each score. It doesn't really have to be in ascending order, but I'm going to change them to ascending order. So this is just the score. And now I'm going to do the score minus the mean. So for each of these numbers, I'm going to subtract 7. Again, you absolutely don't have to find a standard deviation by hand on the test. You can use your calculator, and I'll do it on the calculator in a second. So I took each of the scores and subtracted the mean. Now I'm going to square these. Negative 3 squared is negative 3 times negative 3, which is positive 9. So I'm just squaring each of the numbers. Now I'm going to add these all the squares up. 9 plus 4 plus 1 plus 0 plus 4 plus 9. Assuming I added these right, 13, 14, I get 34. The standard deviation is going to be the square root of that number 34 divided by 1 less than the number of items in this column. And there's 6 numbers in this column. 6 minus 1 is 5. So I'm going to do the square root of 34 divided by 5. And I get 2.607. It says round to the hundredth, which is 2 decimal places. So for the standard deviation, I'm going to write 2.61. I should be able to easily get this on my calculator. So 2.61 is the number I'm looking for. To get it on my calculator, you'd hit the Stat button, make sure the Edit and 1 is highlighted, and hit Enter. Arrow up to the top of list 1, hit your Clear button, and hit Enter to clear the list. Now type the list in any order, so 4, 7, 6, 5, 9, and 11. So that's just the every number that's in my data. It can list it in ascending order, but it doesn't matter. Once you have the list just with the right items, you hit your Stat button again. You arrow over 1 to Calc so that you have the Calc darkened and the 1 variable Stats darkened, and you hit Enter twice. And this number, this SX number, you see 2.607, that's exactly what I got when I did it by hand. That 2.6, this SX, S for standard deviation, I get 2.61. You'll notice that in there it gives me the mean, which was 42 anyways, but that's not really such a big deal. Okay, so now let me do problem 8. Problem 8 basically says take all the data pieces and add 5 to each. So the data in number 7 was 4, 7, 6, 5, 9, and 11. I'm going to add 5 to each one of these. So the 4 is now going to become a 9. The 7 plus 5 is 12. 6 plus 5 is 11. 5 plus 5 is 10. 9 plus 5 is 14. 11 plus 5 is 16. So that's adding 5 to each of the pieces of data in the set. Now I'm going to find the range. Range is just high minus low. That's going to be 16 minus 9, which is going to be 7. And I'm going to find the standard deviation. I could make another table and do it by hand, but you're not required to do that. Let me just do it by my calculator. So I hit my Stat button, get the Edit and the 1 highlighted, and hit Enter. Arrow up to the top of list 1, get the L1 blackened out, hit the Clear button, and hit Enter. Now enter the data either in the order that it's given or any order that I'm comfortable with. So there's a reasonable, the data's in. Notice I have other junk in here. The other junk doesn't matter. My calculator could ignore that. Once I have the list 1 with all the data pieces that I need to have, at my stat button again, I arrow over once so that the calc in the middle column is highlighted and the one variable stats in the left column is highlighted, and I hit enter twice. And I look for the number that says S sub x, that's the standard deviation. And I get 2.607, which is 2.61. If I look at the answer to my last question, it's exactly the same standard deviation, exactly the same range. Just adding a number to a fixed number to a set of number, it doesn't change the range of the standard deviation. If you multiplied all the numbers by a number, that will change the range in the standard deviation. So that's everything I have on the review. So it's hopefully a nice, friendly, short chapter that you could do well on the test for. So let me shut the video off now. And again, if you're feeling a bit overwhelmed, if there's something you just don't quite understand perfectly, send me an email, come visit me, ask me questions in class, and I'll try to make it better.